welcome everybody. I hope it's I think afternoon there, right? So I hope you had a good morning and an afternoon. And yeah, how many of you are interested in knowing about engineering? Okay, that's nice. How many of you are planning to go into the field of engineering? One, two people. Okay, so maybe I can start by sharing my screen. 1 second. Yes. Can you see? Okay. How are we going to do this? Are we all going to be on mute? Is that a rule also?
No, you can go ahead and they're free
So
to
I can
answer.
ask questions and
yeah, you can make it interactive. No problem.
Okay. Thank you. Nice. So yeah, Daphne gave me this topic to present to you. It's called engineering and research. So mainly we'll be talking about different branches of engineering, how they all, what you need to know about each branch and what fields they are involved in. So yeah, can someone actually identify these pictures for me? Is it possible? What field of engineering do these belong to, or what are they? Anything look familiar, or it's all very
Automobile?
Robotics.
Robotics, okay. Automotive, yeah. And then the rest?
Programming or something?
Which one?
Programming or something with the computer chip?
The computer chip, yeah. Programming, but it's also electronics, right? You have to design the chip. So that's something else. That's a different field. And then the chip is used for computing, for instance, or something else also. Yeah, so let's continue to the next slide. So the first slide I've created is to talk about science versus engineering. So who can tell me what is difference between science and engineering, or is there a difference? When you think about science, when you think about engineering, what comes to mind?
Science means like finding things and exploring. Engineering means like building them.
Engineering means?
Building them,
building them, yeah. So science is more about exploring the laws that work in nature, right? So laws of physics or the chemistry, how chemicals react. That's science. But when you take what science discovered or developed, and you put it in practice, and you apply it in everyday life, and you build something or use science, that's engineering, right? So inventions and building stuff, those come as engineering. So you use what you learn in science, but it doesn't say in theory, but you actually put it in practice. That's what engineering is. So you have to engineer stuff, right? Things are the way they are in nature, and you take what is in nature and you do something with it. And that's the field of engineering, right? So you can either choose to become a scientist, where you'll be doing a lot of research into and finding new laws or theories. You'll be working in labs, for instance, to test your theories, and then you can write papers and publish them, which is a very important field. But then an engineer should have the capacity to take those theories and take those publications and do something with it, right? Build a product or build something with it that people can use, and which benefits society and at large, right? So that's the difference. That's the the small nuance difference between science and engineering. So let's we'll go into the main branches of engineering. How many of you are familiar with these branches? Show of hands, or yeah. So how many of you have maybe relatives in any of these, and they have some idea of what they do? For instance, if your parents are doing civil engineering, they know you should know something about civil engineering, right? How many of you have relatives in these fields? Okay, 2. All right, 3. Okay, so let's go by one through these fields. So these are the main branches. There are many more branches, but you could take these main branches and then say those other branches are a subclass of these branches, for example, right? So in traditionally, engineering is classified as civil engineering, electrical, mechanical, chemical, and software, right? So in civil engineering, what do civil engineers do? What is civil engineering?
Construction, buildings, and
Yeah, building buildings, and so they build buildings. But do they build buildings, or are there other people building them? And
they give the plans for the buildings.
Yeah. So they draw the plans for the buildings, and they also do things like what do you say? You also have to choose the material for what you build, right? So they need to know how to build them. So you have to draw the plans. You have to know what to use for each part of the building, and you should know all the tools required for the building, right? So they have to do a lot of planning and calculations, for example, right? And what do these people have to know? Like what skills should they have, right? So if you are thinking about, am I going to be a good civil engineer if I study civil engineering, right? What should you know? Do you understand my question? Like, what skills should the engineers have? Can someone tell me? In order to build a building, what skills should you possess?
Can you even type it in the chat box if you want to answer?
Okay. There's chat box.
You should like physics, the subject.
Yeah.
You should know about the metals and all. You should have awareness of all the things around you, and like maybe even the environment. So
Yeah.
you should know what kind of, maybe the places that you can build, what kind of buildings will stand in that place, the climate, sustainable.
Yeah, that's really good. Yeah, so they should know physics. You should have a good understanding of the environment. That's very good. Yeah. And then what else should an engineer know? Civil engineer. Should they also be able to draw the plans, right? Like they should have a spatial awareness. They should be able to do some calculations, right? You should be able to understand by looking, like for example, you should get a grasp of distances. You're looking at a piece of a metal bar, for example. You should, just by looking at it, you should have an intuition for how long it is or how wide it is, right? That's a good skill also, right? So those kind of things, that's what a civil engineers need to know. So yeah, so when you do when you want to become a civil engineer, you would ideally in your school, you should ideally take these courses on mathematics, on physics, and also chemistry, because you need to know the materials that are involved and how they hold up, right? And it also comes in environmental, understanding the environment that you're building the buildings also goes a long way. And then eventually you would go into an engineering program, right, to study this in further. A lot of people who like to draw take up this field because there's a lot of drawing involved, a lot of spatial awareness, right? Okay. Let's go next to the electrical engineering. Now, what do you know about electrical engineering? Anybody?
They deal with electricity.
Yeah. And what is, why do we need electricity? What's so special about it?
Maybe in a house, they are the ones who decide how many points, how many plugs, switches, and where they should be, and so that the correct places and how they're connected from the main, the pole.
But what about civil engineers? When they build a house, don't they also decide where the plug should be? Then they can plan the house, right? How the, yeah.
Maybe they're more experienced, or they know more about, like when you go for a much bigger project, they're more capable of doing, like related to electricity.
Yeah, so that's a good point. So when you go into buildings, sometimes you have to work together. The civil engineers will have to work together with the electrical engineers to decide where the plug should be, what is safe for the electrical cabinets, and how the wiring should be, right? So there you have like a cooperation between two engineers of different fields to work together. And then what else comes under the electrical engineering branch? There is also a large power lines, right? You see substations, generating stations. Those stations need a lot of electrical engineers who can build these power lines, right? So how does power come to your house? Okay, somebody said telecommunications. Yeah, so telecommunication. Yeah, I'll come to telecommunication. But how do you first power lines? How do you think power comes into your house? It has to travel through some medium, right? What is that?
From a power industry.
Yeah, that's true. So how do power industries get power? They have to generate power through some. There are generating stations. For example, hydropower. You get power from the water. You get power from coal or gas. So there are so many sources of power, and then you have to transmit. You have to convert into electricity and then transmit through these power lines. And electrical engineers who studied that subject, power system engineering, they can design these transmission lines. They can design the substations, which substations are again others like smaller stations which can facilitate transporting power to different areas of the place, like different areas in the country, for example, right? And so that's what power system engineers do. That's a branch of electrical engineering. And then you also have electronic engineering. What do you think electronic engineering means?
They're the ones that deal with the computer chips and programming.
Programming is still another field, but electronic engineers design the computer chips or any other chips, for example. It could be also, you could also make electronic boards to convert power. So if I have a very high voltage power, I can convert to a low voltage, or I could convert from a low voltage to a high voltage using electronic chips, right? Electronic circuit boards. And that comes under electronics. So that's like the main two branches. Electrical is high power, and electronics is lower power, right? You'll see that in your computers, in your mobile phones, those things. That's what electronic engineers design or develop. So, and then you have other fields like telecommunication. Daphne was saying telecommunications again, how to transmit information through the airwaves, for example. That's telecommunication. So you need that for your mobile phones or for your internet. You need to transmit data through the airwaves, and that's you can use that. You could say that's again a subfield of electronics, because you need electronic chips to be able to transmit this data, right? You must have heard of 5G and 4G. All those are different generation, different technology of how fast you can transmit the data. That's like the great research that's happening in telecommunication. So every 10 years, you're supposed to go into the next generation. That's the idea. And then what do these engineers need to know? What skills do they need to possess to be a good electrical engineer? What do you think?
They need to know physics because they deal with electricity.
Okay. Then physics, yeah. Then
A little bit of architecture as well, since they're building power lines and they deal with the electric circuits in the house.
Yeah, that's true. A little bit of architecture, but it's not so important, because the power lines, the main idea behind power lines is to make it safe, right? So it's really electrical engineers know what components need to go to make sure. For example, there should be a certain distance between cables, and but you don't need to know. Yeah, for example, you don't need to know the structure of the tower. You don't have to build the tower itself. You don't need to design that. That's more for the civil engineers. But the electrical engineers would tell the civil engineers how far the cable should be apart, how long it should be, and things like that, so that the power goes safe there, and you don't get any loss in the power cables. Yeah. So they need to also know mathematics. So that sometimes you might not be clear about, because how is mathematics used in this? But there's a lot of mathematics going in to electrical engineering. So if you're planning to take this subject, you should be good with mathematics, or you should like the subject. And then you have oftentimes mechanical engineering will also come and play with electrical, but we can get into that later. Then also you'll also, when you do an electrical engineering course, you'll also do a lot of software, because a lot of these chips are designed in softwares, and yeah, so there's a lot of programming that you could encounter in electrical engineering. So that's yeah, that's kind of the electrical engineering point of view. Do anybody have anything to add? Like they have questions or something they want to ask at this point?
If there's a particular like field that I think it would be ECE and EEE that focus on electrical engineering.
Yeah. Also, there's also something called instrumentation engineering. So you would have, primarily it has to do with sensors and how they communicate with each other and how to configure sensors. Also, like automating of machines fall into that field. Yeah, but the thing is, when you go into, it's very difficult also sometimes to separate fields. So many times engineering will be like a mix, interdisciplinary. So you'll have a lot of overlap between electrical, software, mechanical. These three are the main three fields that keep having to work together. But yeah, for now I gave you examples where it's mostly electrical based. And but later on I'll talk about where these fields overlap. That will be more interesting, I guess, and you'll see those things happening more and more in everyday life. Yeah. Okay, so we'll go to the next field. Hold on. So next is mechanical engineering. So usually all the boys like taking mechanical engineering for one reason. Why is that? Can anyone tell me what the reason is for doing mechanical engineering? Or what comes to mind when you think about mechanical engineers? What do they do?
They deal with machines, the working of machines.
Working of machines. But do machines work on their own? If you have built something, how does it move? It needs some sort of power, right? So what do mechanical engineers do? They design machines, for example. They can also build them, right? That's what mechanical engineers do. But when it comes to maybe if you have a moving machine that moves, then you need some power to go into it, right? So that power can either be electrical power or mechanical power. Electrical power is something you already discussed earlier in electrical engineering course, the branch. And then what about mechanical power? Can you give me an example of mechanical power? When we push something, that's mechanical power, right? That's our body giving power to something else. That's mechanical power. So one good example of mechanical power in practice is in automotive. In a car, we have an internal combustion engine, right? So the fuel burns in the engine and produces power, and that's mechanical power. You have you can also use not in automotive, but in machinery, you can use hydraulic power. That is, you use the power generated by water. That is, you can force water out through a funnel and then produce hydraulic power. And then there is pneumatics, which is again pressure. You use pressure to produce power. So these are examples of mechanical source of power. Mechanical engineers they'll have to learn about these sources and also how to design parts of the machine so that they work together and do not break down, right? So the parts have to work in together in a sequence, for example. But also, so when you think about mechanical engineering, what do you need to know in mechanical engineering? What skills should you have? Anybody? Mechanical engineers should know physics, right? How the parts, the laws of physics, how do machines move, or how do things fit together. They need to know something about structural engineering, that is, how much weight or how much force, how much load can the certain material handle, right? And they also need to know a lot of mathematics. You have to you'll have to write formulas to explain certain machines, how they work and how they can function properly. And many times mechanical engineers also learn to program so that they can program the machines. And also, there's a lot of software involved in designing. So they'll have to learn those kind of programming involved in designing different parts of machines. right? Well, there are also subfields of mechanical engineering. Can you name a few fields that, yeah, if you specialize in those fields, then you become like you go into a different field. Like, for example, in electrical engineering, you had electronics, you had telecommunications, you had power systems. What about in mechanical engineering? Can you name a few?
Like you can design machine.
Yeah, designing of machines. Yeah, you could say product design, for example. And then,
Is hardware engineering coming under mechanical engineering?
sorry, software,
Hardware.
Yeah, you could, but usually hardware is generally the term is used for electronics. So there is when you come into, yeah, what do you say? For example, making of a mobile phone, you'll have a hardware. That's the chip itself, the whole electronic architecture. But you have the software, which is the programming. So that's how they distinguish between hardware and software. In mechanical engineer, you wouldn't call it hardware, because everything mechanical engineers do is really hardware, because it's not software. The software is only used for designing the hardware, you know. So you don't call them hardware engineers, you call them mechanical engineers. Yeah, that's a good question. Yeah. What else? What other fields of mechanical engineers are there? You have, for example, automotive, right? So automotive is a branch. You could say it's a branch of mechanical engineers, because you need to know the mechanics of the car, how the engine works, how you would design the car so that it gives you the optimum, like you have to design it in a particular specs, right? You have to go at certain speed, you have to go at a certain acceleration, you have to brake at some point. So all those come into designing of an automobile. And then what else do you have? What about drones? Where does drones fit in? I think it's becoming more and more common to come across drones. So drones are like a field called aerospace, right? You need to know how machines go or work when they're flying machines. Also, you have people sending space shuttle into space. That's also aerospace. Also, aeroplane fits in that field, right? You can't put aeroplane in the field of automobile. They are moving machines, but they are flying machines, right? So you need to know a lot of aerodynamics in that. And yeah, so and then there's manufacturing. Then you go into these manufacturing plants, and you need to know how these machines are made. So for example, in the company I'm working for, they make machines that can cut metal pipes. So you need to know how that works, how to operate those machines. So those kind of things also come into the manufacturing field in mechanical engineering. Okay, so let's go into next, the chemical engineering. What comes to mind when you think about chemical engineers?
Chemistry.
Chemistry, yeah. And so what do they have to do?
They
One
deal
real life
with
application of chemistry. Can you name? This is quite common in. Oh, sorry. Daphne said dynamo. Is that for the mechanical or
Yeah.
chemistry? Oh, sorry. I missed that. Yeah, I'm not too sure of. I don't know so much about dynamos. I only heard the name. Sorry, I can't speak so much about it. So chemistry, I think it's quite common in Saudi Arabia. Chemistry, chemical engineers. Can you name one real life?
with petrol.
Yeah, petrochemicals, right? So they need to know how to refine petrol, what is it, natural gas, into basically petroleum into different products like natural gas and LPG, and yeah, there's a lot of products I think you can get from petrol. And also, yeah, there are a lot of refineries that make use of chemical engineers. So these engineers know how, in what proportions you have to refine these naturally available raw materials to get these different products that are good for everyday use. Right, that's chemical engineers. And also, what other applications? What about nuclear power? Nuclear power is also chemical engineering, right? And also physics. So it's a combination, you can say. What do chemical engineers need to know?
So I have a doubt.
Yeah.
So a scientist finds out these how to create or make different compounds out of maybe one element, that is carbon, and maybe chemical engineers, they use it very, like, they don't find it but they use it, right? Is that the difference between both of them? So it's like more like an occupation to use it, and maybe like as a continuous product, right? They don't find out anything in chemical engineering. They use the already given formulas or already there elements.
Yeah.
Is that how it is?
Yeah, that's true. So chemical engineers need to know how these things can be done in, for example, in a large scale, right? In order to make profit out of, make it an industry, right? Make profit out of what the chemical scientists, they have already discovered, right?
Okay.
So for example, if you like a nuclear plant, you know, if you have radioactive element like uranium, you can generate energy from it. And then the chemical engineers say, okay, or chemical engineers and the physicists come together and say, okay, I can use this to use this energy to power maybe some plant, right? Energy to generate electricity. So that's what the chemical engineers do, and they'll be able to design the whole plant. They'll be able to say, okay, I need to have certain tanks, certain pressure valves. These chemical have to be put in certain pressure, you know, these sort of environments, so that to get the best results. Those kind of calculations the chemical engineers should be able to do. But if you say, do they not find out anything? They do discover things. They do research. If you want to go into research, you can do that. That's when you might be able to do research on how to optimize this particular plant, for example. So that might be a technique that has not been discovered, has not been developed before. So nobody knows about it yet. So you could go into chemical engineering field and then do research to find out these new techniques. You know what I mean?
Okay.
And then
so
you can publish paper. Yeah.
I mean, I'm sorry, but do you get paid for doing that? I mean, do what do you say? Companies hire you for that, or is it out of your interest you do it?
Yeah. People. So the companies need research. So if they find a problem that they cannot solve, right? They have been doing already tested and tried methods for so long, but they have come across a certain problem, which is new, or nobody has found a solution to. They'll have to go and depend on people who are doing research, right? They'll have to
So would they prefer a scientist or a chemical engineer?
Yeah, scientists. No, that's a good question. Scientists don't do it's a different thing, because chemical engineers, they know how things work in practice. Right? That's the difference we've already established. Scientists understand the laws at work. They can explain, they can test theories, and they will be able to tell whether these theories are right or wrong. Right? They're true or false. They are testable, and they should be able to prove it. They can't just say, okay, this thing is good, this theory is right, or it works. They should be able to show. So they do a lot of experiments, but it's always going to be in a laboratory, right? And whereas engineers, they'll be able to solve problems that come in practice. So if you're building a plant, for example, a chemical engineering a plant, or if you, for example, if you take the example of an automotive engineer, yeah, they build cars, but you come across you've been building cars in a certain way for forever, right? You know how to build a car. An automotive engineer knows how to build a car, but then
Yes.
you might have to do research in order to improve that car, right? You don't,
Yes.
the scientist doesn't do that, the engineers do it because they know how to build a car, right?
Okay.
But a normal engineer who hasn't taken the time out to do research might not be able to improve on the design, right? They'll be able to, from whatever limited experience they have, they'll be able to do some modification to improve the car. But if you have to go into an entirely different design, or you want to test whether this design works, that's when you need to do research. You might have to spend few years to do research. So for example, the most important, maybe most common example you can point out is cars have always been in the internal combustion engines, right? They have always, you put petrol and petrol burns inside the engine and it produces energy, which drives the car. But now we're moving into electrical cars. So you charge batteries, then you convert that into energy to drive the cars. So that research had to be done by somebody, right? So you have people who become engineers, and then they are interested in certain area, so they do go into research in that. So you will have, for example, PhDs or professors doing it. You'll also have people in companies doing research. It's called research and development team. So the company hires people just to do research. They'll also be researching on real life products. So these people have the advantage of being able to put their research in practice. So that's kind of how we would see it. There's a lot of overlap. It's a good question you ask. It's difficult to answer. Don't scientists also do this? Sometimes scientists might come into the engineering field and might do research there. That's true. But their focus oftentimes is different. And yeah.
Thank you. Thank you so much.
Yeah, you're welcome. Then, so what should you know? What skills should you possess to be a good chemical engineer? Good chemical engineer. You know chemistry, right? Chemistry, and then physics, and then mathematics. I think mathematics goes into all the fields. It's very crucial. Can you name a few fields that could be seen as like a sub-branch of chemistry? Chemical engineering. So
anything to do with plastics?
Yeah, plastic. Yes, that's a good. Yeah, I didn't mention that. Yeah, so that's synthetic material, like polythene, what's it called? I don't know.
Polyester.
Polyester. Yeah. So that's chemistry. Yeah, when you're creating new material from chemical products. Then, what about, have you heard of this field called biotechnology? So there's a lot of, yeah, you could say biotechnology is a new branch that came out of chemical. So there is, in chemistry, you have inorganic and organic, right? Organic deals with the living, with life. You could say biology is a subset of that organic part of nature you see. So biotechnology could be classified as a subclass. Biotechnology engineers in biotechnology, what do? They make, for example, they develop medicines and pharmaceuticals, right? You also have a mixture of electronics involved in how do you say that? You have biomedical instruments. So that's like instrumentation with applied in bio or medicine. So you have, for example, nowadays they're actually developing robots to do surgery, do medical surgery. So you have electronics involved in the medical field, right? That's not really, the doctors cannot do that. The doctors cannot develop these machines, right? But you need to know a little bit of biology in order to build machines for medicine, for the medical field. So that's different from being a doctor, right? That's more of a work of an engineer. Yeah. And then then we spoke about petrochemicals. So petrochemical industry hires people who are called process engineers. They can develop, they know chemistry, they know the process behind chemical equations and what process actually gives you the product that you want. Yeah, and they'll be able to build, design these plants, right? Petrochemical plants. They'll be able to draw the layout and tell what what components go into this plant, what sort of pressure valves or tanks that you need to have, and what chemicals in which proportions that you need to have in those plants. So that's a field called process engineering. That's also like, chemical engineers can do that, I would say. Okay, so that finally we go into software engineering. How many of you can tell me what software engineering is?
They are involved with programming?
Yeah, programming. Where do you use programming?
When you generate if you want to generate a new app, if you want to like the basic what does the app do? To make the app do what it does, you have to come up with a certain program.
Yeah, that's right. So program is, you could say, it's a series of instructions that you give to a machine, right, to do certain tasks, right? So programmers, they can develop these software, that they can develop these set of instructions so that the machine or the device will do as you want it to do without any problems, without any bugs, right? That's what software engineers do. So what do they need to know to be a good software engineer? No, what skills should you possess?
You should know programming.
Yeah. Then
at least the basic.
Computer
and
science.
what other? Sorry, I didn't get that.
Computer science.
Computer science. Yeah. Computer science. You need to know mathematics.
You need to know code like Java or.
Yeah, the language, the programming language. Yeah, you need to know that. That's good. Then there's also a lot of logic involved, right? If you do this step, you go to the next step. So those kind of what happens. You have to think ahead, to think logically, to know what your program will, what you potentially do, right? And then you need to also know electronics. Some parts of electronics, you need to know how much memory or how fast your computer can process your set of instructions and things like that. So there's software engineers also know a lot of electronics. They might have to choose certain parts over another part, certain components of of the electronics over. They need to make those decisions. Why am I using this part and not another, right? And why do I use certain programming language and not another? There are a lot of programming languages out there. You have to make those choices. So those kind of things, that's what software engineers do. They also write an overview. They'll have to know an overview of how their program should look like, and then they do coding, right? What fields do software engineers, what fields are they occupied in? Can you take a guess?
When they're making robotics,
Yeah.
Program for robot.
Yeah. Then?
Maybe all the machines even used in medicine, like a dialysis, all those machines, they need programming.
Yeah.
Maybe
Why do they need programming?
Because like if you have to check, even in our smart, like our watches, there's this option where they check our heartbeat. So if they have to check that are a series of programs or code they must have already applied, so that when we just click that, these many options come and they know what to do. So it might be related to programming or software engineering.
Yeah, right. So yeah, when it's digital watches, yeah, you have programming. Otherwise, you just have only one or two features. You can't do much more than that, right? If you want to change on a digital watch, if you want to go from one screen to the next screen, you have to write some coding, right? Otherwise, you don't know which screen to go to. And then, and then the whole synchronizing between different features of the watch. But if you look at an old watch, an analog watch, do you think there's any programming there?
No.
So it's possible to build without programming, but then you have only time, right? So that's the difference. Yeah. So the more advanced a machine gets, you would find that there's a lot of software involved. Yeah. So in the old days, you just needed to see the time. So you could actually go as far as making it purely mechanical. You'll only have certain gears inside, and you'd also find maybe your grandparents using watch you could wind up, and then they unwind, and then that's what makes it tick. And then once it's fully unwound, you'll have to wind up again. So that's purely mechanical engineering with only mechanical power, right? And then you add electricity to it. You put a battery to it, then it runs on its own. As long as the battery has power, it keeps running, and then you change the battery. So you've gone from purely mechanical into mechanical plus electrical. Then now we have digital watches. So that then you have mechanical in the sense that you have to design the watch. That's the mechanics, and then you have to put an electronic board in it. And then you have to write some program on it so that it does what you want it to do. And then you have a lot more features, like Sharon said. You have you can see your heartbeat, you can see time, you can do a lot of, you can maybe connect your phone and get alerts, things like that. So many times nowadays you'll have these three fields coming together to do big to build machines and build products. So that's often what you see in real life. So that takes us to the next topic, interdisciplinary fields. Yeah. So I'll show you a picture. You have to tell me what all fields, what all things that you think needs to go into it to build this. Yeah. So what do you think this is?
It launches the ball.
Yeah, that's all. Take a guess. There are three of those, right? In something that looks like a field with a goal post behind it. What do you think these things do?
One is the goalkeeper, one is the fielder, maybe.
So so you're saying they actually play football, right?
Could be.
Yes.
So what do you think you need to know in order to build something like this? What all fields of engineering is going into it?
This requires software programming if it plays football by itself.
Yeah. So this is a fully autonomous robot. So there's nobody with with a remote control moving it around. So it has to make decisions on its own. Then what else?
Mechanical.
Yeah. Why? Mechanical engineering for what?
To design if the parts.
To design the parts. Yes. Then what else?
Use of sensors.
Yeah. Why do you need sensors?
So it knows where the ball is, the motion, so it can detect and thereby go to the same place where the ball is, so as to catch the ball or launch it.
Yeah. And what else do you need sensors for? Is it only the ball that's...
To make sure you don't hit somebody else.
Yeah. And also you need to... So this is... You have to think like a team, right? You're playing football. You're not only looking at the ball, you're looking at other players. You're looking at what's happening in the field, right? How should I progress? So all of that needs sensors, right? Then what else?
Electrical engineering.
Yeah. And why is that?
So where the electricity should pass and how much it will be needed. Is it supposed to have a low voltage, high voltage? How much should it?
Yeah. So all these this is completely powered by electricity. So you have all these. Okay, for example, I have a question. To launch the ball, you have a moving part, right? But what moves that part? So the part itself is designed by a mechanical engineer, for example. But what moves the part? You need something to move it, right? What do you think moves?
Power, electricity.
Yeah. But if you put just a wire, if you put a cable onto the part that moves, does it move?
You little bit of programming as well. Yes.
So you need something called motors, right? Motors power the moving part, the actuator. So the motor is a electrically driven device. So you have a lot of motors in this. You need to push the ball. You need to move. To move also, you have motors. And yeah, so there is just to operate the motor, you'll have electrical, you'll have the mechanical part, and you'll have software. Like Joshua said, you have to regulate how fast you want to move it, at what time you want to move it. So those kind of things. Those instructions. If you're just moving it all the time, then you could say you just need mechanical and electrical power, right? But if you want to move it by thinking about it, that's the brain. It comes from the software programming, right? You need to know when to move it, how fast you want to move it, in which direction you want to move it. So those kind of things come from, those decisions are made by the program that the software engineers develop, right? So then, yeah, so that's good. So you learned a lot about somebody said, one more type of engineering, aerospace. Yeah, I'll come to that. Just 1 second. Okay, so next picture. What do you think goes into this?
Automotive engineering.
Yeah. But what's special about this car?
It's solar
Have you
power.
heard of... Sorry? Solar power. No, this is not solar power.
Is it electrical?
Not sure. It could be. It could be in normal car, petrol car. It's yeah, it's not too clear from this picture, but it says self-driving on it. So what you see on top, those are sensors. So the car sees the environment around it using those sensors, so that it can drive on its own. Yeah. So what do you think is needed for this? What technology?
Software engineering.
Software engineering. Yeah. So it's similar to the robotic, the soccer robots, right? It needs to know its environment. It needs to sense, and it needs to make decisions on its own. So the decisions making is the part where the software engineers come into play. Okay, and then the car itself will be designed by
Mechanical engineering.
Yeah, mechanical or automotive engineers. Yeah, and then if it was an electric car,
Electrical engineering.
yeah, electrical engineers. But also because there are sensors, you'd also have a lot of electronics going into it. To take all the electronics part will take the sensor readings and give you, and they will basically analyze all the readings. You need electronics and software for that. Then you have the automotive part. This car needs to go. It needs to be designed a certain way to go places. Yeah, so that's like a normal car. Finally, we come into drones. What do you think goes into this? Somebody asked me about aerospace. Yeah.
Aerospace engineering.
Yeah. Why aerospace?
Because it flies.
So what's different from flying, between flying and moving on the ground?
This involves much more physics.
Yeah. So it's different because if you look at the size of each of these, you would see the drone is the smallest, right? There's a reason, because you can't, with these four fans, what do you say? Not a fan, I think it's a propeller. So the four propellers can only carry a certain amount of weight. So you have those kind of calculations an aerospace engineer can do, right? Because with these four propellers will generate certain amount of power, certain amount of thrust. And with that, they'll be able to say, okay, we can only carry so much of weight. And then the electronics people, they need to say, okay, with so much of weight, how much electronics can I add? So they have to try to minimize the number of electronics. Electrical guys will have to say, okay, the battery is going to weigh a lot. Now I need to run the drone for, say, 10 minutes. How much battery do I need to put on the drone? Mechanical engineers will then say, okay, if I lengthen for example, the distance from the propeller to the body, maybe I can fly longer, or maybe I can carry more weight. So those kind of decisions mechanical engineers can do while designing the drone. Right. So you have all these fields coming into play just in this one small drone. Right. And the more, if you make the drone fully autonomous, you have more software, more electronics involved, more advanced technology. If you make it remote control, right, then you don't need a very intelligent system. You are the intelligence that drives the system, right? So that's the difference. So somebody asked about aerospace. This is a good example of aerospace engineering. You also have aeroplanes that make into use aerospace engineering. you have shuttles. Yeah, so those kind of things. And you also, if you also look at, there's a lot of research now happening in cars. Yeah, in for example, Formula One, those cars go really fast. So even the smallest, when the car goes really fast, even air can be a hindrance, right? It might not be windy, but since the car is going really fast, it goes through the air. And this sort of calculation or simulation, what happens when the car goes in real life through the air, like not through the air, it's running on the ground, but there's a lot of air resistance. So that's something an aerospace engineer can do, because they deal a lot with what happens when machines move in the air, right? So they designed Formula One cars so that they give the least amount of resistance. They try to design in such a way that they will produce the least amount of air resistance. So that's, yeah, when you're trying to, when all the cars are going really fast, you're trying to compete, every small optimization, you can call it, will make a difference in whether you win or you come last, right? That's a good example of where aerodynamics, they call it aerodynamics, is involved. Then what else? Any other questions based on what we already discussed? Or is there any other field that you know of that I have not covered?
I have a doubt, actually.
Yeah.
Machines like ships that go on water or submarines, they come under automotive?
Yeah, well, not really automotive. Yeah, not sure. They could be under, so mechanical engineers work on those. So it is building a machine that goes on water. So instead of flying in the air, they'll have to also do research about what happens when you're on water, right? How does a machine, how does a vehicle move in water? So that's again, yeah, they call it fluid dynamics. So air is one fluid. There's also water. You need to study the dynamics of water when you pass through it. So mechanical engineers study that, and you can go in, you can then later you can specialize in fluid dynamics, for example. Yeah, that's a good question. Yeah. Then any other questions? Jonathan, did I answer your question about aerospace?
Yes.
Do you have any other question about aerospace? Okay, if there's no questions, then go to the next slide. So here I made a slide. It says, what degrees do you need to do in engineering, or what all degrees are there that you can study? And so you start with a bachelor's. They usually call it a BSc or a BTech. It's bachelor's in science or bachelor's of technology. So that's where you start. It's usually a 4-year course where you study either of any of these fields. And depending on the university you go to, you'll have different options. So the ones that I've listed, civil, electrical, mechanical, all those are the main branches of engineering. You'll also find more other branches like communications, like instrumentation, or biotechnology, biomedical. So depending on the university or the college you go to, you'll have different options. You also have some colleges who only have mechanical engineering, but others will have mechanical, automotive, manufacturing. So those are the different fields. But many times you'll see if you stick to the it'll be a good idea if you do an undergrad in like a bachelor's program in the big umbrella branch. You know what I mean? Like if you do mechanical engineering, and then later you can decide to go into aerospace or automotive, that would be a good idea, because then you know more fields and not just aerospace or automotive, right? And oftentimes you'll also see people go from mechanical engineering, then they do electrical engineering masters, because they wanted to do something that combines both, like robotics, right? So they want to know more about they got an idea of what mechanics are involved. Now they want to study electrical engineering. That's also possible, because more and more you will see people are doing interdisciplinary fields, right? Like, for example, building a self-driving car. It's not only enough to know an automotive, how a car functions from an automotive point of view, but also you need to know the electronics, you need to do software. So people are more and more involved in interdisciplinary fields. But if you're interested in doing engineering, you would ideally start off with doing a bachelor's in the field that you like. Then if you think you're interested more and you should specialize, and you would do a master's. And then finally, if you want to do research, study a particular topic more in depth, publish journal papers, then you would do a PhD. And PhDs are usually a 4-year program. So you would then you would get a doctorate degree, in which case you will be like almost like an expert in that field. Yeah. Any questions about this? So a bachelor's would usually take 4 years to finish. A master's is usually 2 years, and then PhD is 4 years. That's how it goes. Sometimes you also see people who do, for example, software engineering. It's a lot of coding. People start off even before their bachelor's, so they know they have some experience with coding. And there are examples of people who don't even do a bachelor's. They try to get employed with whatever skills they have. That is also possible, but it depends. Some places like in India, they give a lot of emphasis on having a degree. Then you need to get a degree. Degrees are a good way to show what you know, but oftentimes in software development, you can also put up codes online, which you can then show. If you find an employer who is interested in knowing what you've done, what projects you've done, you can always show them what you have. You can put it online and show it to them, things like that. Yeah, there's more options. Any other questions? Somebody asked. What is that? OND.
I guess it's a typo. Johnson, if you have a question, you can just type it again.
Or you can ask also. Okay, so if there's no questions, I'll go to the next. So this is the career progression, right? So in careers, you can broadly divide the two branches, you could say, or two paths you can take in engineering. What is petroleum engineering? Petroleum engineering is, again, like a subclass of chemical engineering. It deals with how do you refine petroleum, right? You can extract petroleum from the earth, and then you can take it through a refinery process in a refinery plant, and then get other products like natural gas or Yeah, I don't know what a diesel and different things are there. That's what petroleum engineering deals with. Right. Okay. Then yeah, so there are broadly two career paths you can take in engineering. One is in academics, the other one is in industry. In academics, that is, you can work in a university where you do research and you teach the subject, right? So at some point you have to ask yourself, okay, what career path did the teachers who are teaching in the colleges I'm attending take, right? So they would have to do a bachelor's, a master's, and a PhD, and then they would start teaching. That's usually the way they go. So in PhD, you would do a lot of research. So ideally, usually PhDs, how they work is they would get a guide who is a professor at the university, and they would select with in collaboration with the guide, they would select a topic. Usually how they do is the professor would put up advertisement, just like a job opening, saying these are the projects that he has funding for and he's involved in, and whoever is interested in working on those projects can apply. And so a student who has done finished a master's program, or who has a degree, who has a master's degree and want to do PhD, he can apply for it. And then if the professor, there will be an interview process, professor takes him on board, and they will define what topic his project will be. So his 4 years thesis, what exactly he's going to be doing in that field. And then he will, in the span of those 4 years, he will be doing a lot of research, doing experiments, publishing papers in journals. And then he will also be assisting other people, like for example, master students also doing their projects. And he'll be involved in a little bit of teaching, helping out the professor, his guide, in that field that he has taken on. So that's what PhD does. So he has a bit of research, bit of teaching, and publishing, those kind of things he'll be doing. Is that clear? Then after you do a PhD, if you want to do more research, you can apply for a postdoc position. That is basically postdoctorate position. So you might do more research in the same field. You might change university, you might go to another university and do, basically it's just a for example, 2 years more of research in the same field. So you get more research experience. And then if you decide, you can decide to become a professor. And then later, if you're really good at that topic, you'll end up being head of the department. You'll be recognized as someone who is like an expert in the field, right? So for example, you take up automotive and you specialize in electric vehicles. You go all the way to becoming a professor and then the head of departments. And then if you keep going up the ladder, you'll be world renowned in that field, in electric vehicles. And you can, then you'll be also involved in advising companies on how they should develop their technologies, for example. So that's the academics. People also go do a PhD and then go into industry. That's also possible. The other path is do a PhD. You like the field so much, you want to do a PhD, and then you realize, okay, but I don't want to continue in academics. I want to know what's happening in the industry. I want to apply what I've learned. So you can go and do research for a company, for example. You can be a research and development engineer for a company, or just develop your own product, because you know so much about the technology, you can even build your own product. Yeah. So the next, the next path you can take is in industry. You can start off as an junior engineer, then gain experience, become a senior engineer, and then lead a team of people. and then become like the chief technical officer of the company, right? So you could either do this by doing a bachelor's degree and then starting off as a junior engineer, going into senior engineer. Because you've gained experience, they'll promote you. And then because you have so much experience, they'll ask you to, the new hiring that they make in the company, they'll ask you to lead the team of engineers, right? Because you know so much. You also can, sometimes there are technologies which are more advanced, so they'll ask you to have, they'll require you to have a master's degree before you can even start off working in that field. So then it'd be a good idea to get a master's degree and then start off an engineer, get promoted all the way to CTO level. You'll also find people who, after doing their master's or your bachelor's, they start a company. They call themselves a CTO because they are going to be doing all the technological part of the company, and all the engineers are going to report to them. They're going to make the decisions decisions which involve the technology they're going to make. So they call themselves a CTO. There's a chief technology officer or a CEO, chief executive officer. Yeah, so you'll see in companies that are technology companies, like, yeah, for example, Tesla, right? You'll have a CEO who's also an engineer. You can't, right, because he knows the main aspects of the company. He'll have a very good understanding of it, right? Okay, so finally, I have downloaded a video from YouTube, and this is like, yeah, it's a video of the machine that I work on in my company. You can have a.
Joseph, you've shared the sound, is it?
Oh, wait, let me see. Where do I share the sound?
You can click on again, share screen, new share, right on the top.
Yeah.
And then right at on the left corner, you'll see share sound. Yeah.
Oh, yeah. Okay. So this is a machine that cuts the end of a metal pipe. So there's programming involved to decide how to cut. The pipe comes in, then the operator selects which type of cutting he wants to do. So the tool cuts, you see it spinning, and it cuts. You have to really spin it really fast so that it cuts the metal pipe. You get these things come out of it. You get a shape like that. Yeah, this is a small example of what we do here. But there's a lot of software, mechanical design, and also the motors that drive the turning of the tool. They're all electric motors. So again, you have a lot of interdisciplinary stuff going on in building this machine. That's the end of my presentation. I hope you guys enjoyed it. I hope it was not boring.
Thank you so much. Yes, I think I felt like a newbie just sitting there because a lot of information was new. Thank you so much. And I'm sure that the children are enlightened as well.